Okay, so I'm making this recording because of a question from a Ralstonia colleague who was interested in using our lab's KBase narrative to place a new Ralstonia genome into the phylogenetic context of public data. So our lab maintains some resources on KBase. You need an account. It's free. Um, KBase is very useful, but it's not perfect. And our Ralstonia narrative is kind of hitting some of the limits of what KBase is able to offer. So you might encounter those problems. Um, Okay, so we have this resource that is linked in a bioarchive that our lab maintains. And in it there are about let's see, currently um oh, this is actually version 1, but that's okay. That's similar to version 2. So this is the older version, version 1, which has about 495 genome objects. And so um, enough has been run in this narrative by me that it has some memory problems, and sometimes it can be very slow to work with and load within the computer browser. KBase does do all of its computation on a remote server, but this interface is a Jupyter notebook that does run through the browser, and there does seem to be a certain amount of memory that the computer browsers need to have in order to produce these different windows of the visuals. And in these really large narratives where I've run a whole bunch of apps, sometimes they are very slow and clunky to work with. But that's okay because there are some workarounds that can speed up the process. Um, so what you'll need to do is access the narrative, wait for it to load very patiently. Sometimes you have to make it load a second time. And then you want to make a copy of it. And I think you do that here. For some reason, that is on this narratives pat page, and you can click copy this narrative. That'll then save a copy of this narrative to your account, and it'll save basically kind of a KBase shortcut link to all of the files that were in this narrative. You'll have a shortcut in your own narrative. After you've made that copy, you don't need to really open it again. It's gonna probably have the same slow problems that we have on the parental narrative. So after you've copied it, you can then open a new narrative. So I did that by going here and hitting new narrative, letting this load. Once you have a new narrative open, you can bring data in. Since you've now copied our lab's KBase narrative, it will show up in your My Data page. At this point, I have a lot of data because we've made a lot of narratives. And you can potentially filter it for specific narratives. You can see I really like playing around in KBase. Okay, so this is the narrative that we have all of the public data in. Um, you can then bring over specific data. You probably don't really want the trees. The tree themselves are more useful in the KBase app than these downloadable files. What you're going to look for are some of the genome sets. That's how KBase organizes, a whole grouping of genomes. You can filter that here by going to genome set. Wait. Patiently. KBase, not perfect. Okay. So now there's some different options. So we have this version that says RSSC phylogenomics includes bad quality genomes. And then I've started adding these date versions. So this is the version from January 2025. We're currently working on bringing over some of the genomes that have become available since January, but we haven't quite processed those and put moved them into this narrative yet. So you can always check back to that other narrative, make another copy, and bring over the latest version. Um, And we have two that I'd kind of recommend working with. I'll try to keep all of them with the um, includes bad quality genomes name or having the high quality designation. High quality means that we ran an app called a program called CheckM that looks for completeness and contamination in our genomes. And we've removed any that were contaminated or incomplete. So high quality is what I have my lab use when we're doing comparative genomics, either BLAST or pangenome-based analyses, looking at gene presence and absence across a lot of genomes. Um, for at least KBase level of resolution of what we can do with phylogenomics and making a phylogenetic tree, I choose to include the lower quality genomes in that genome set. There are a few that are sufficiently low quality genomes that they have a lot of mistakes in the genome sequence that does give them longer branch lengths than is accurate. But uh, for the most part, I don't think you really see that. And I've kind of decided to make a choice to be as inclusive as possible to see potential evolutionary relationships. If you ever need to make really careful assessments of the phylogenetic relationship of closely related strains, KBase is probably KBase is definitely not the right tool for that. You need to follow some more rigorous pipelines that you can run on the command line. So I don't have advice for that other than what KBase can give us is pretty good resolution, but not perfect resolution for closely related strains. Okay, so let's say we want to bring this one over. We'll add that genome set over here. It's now in our data. So you can then also bring in your own file if it's in GenBank form. There's a couple different formats you can bring it in. You can bring in your raw reads and then do the actual assembly itself in KBase and get to a genome. Yeah, you can bring in the genome assembly itself. So I'm going to pretend to do that by now just finding one of the genome sequences from this file. So I'm just going to bring this one over and pretend that it's our new genome. Do, do, do. Actually, that might not work. So I'm going to say, I don't want to do that. I'm actually going to delete this. Delete this file. Okay, deleted. Um, and what I'm going to do is just bring over a completely random genome because I don't know for my example. Yeah, I'm worried that bringing over a genome that's already in that file might make my little example here not work so well. Okay, so I brought over a random genome and our whole genome set. So then we will go down here to apps. In this case, so we're going to go to one of the genome set. So I type genome. I know that these are in utilities. In this case, we're going to use the add genome to genome set app. So I'm able to click the genome. The base genome set is that genome set I brought over. And then I'll title this something like Tiffany new.genome set. Um, I always like to do the .genome set. It's not a real file extension, but that just helps me personally keep track of what kind of file things are in KBase. So I'll hit run. That'll send it to the queue. So it's going to be loading. Um, while that runs, I'm just going to explain some other things I like. If I have a whole bunch of genomes in here, instead of clicking as much, you can also use this nice tool called batch create genome set. In this one, um, we'll look at name patterns. So if you happen to have the same thing, like the word genome or the word banana or something in all of the genome names, then these will all get added to a genome set. So this would be like banana dot genome set. Of course, none of these have banana, but I could do roseus. So for example, Roseus, um, hit run just to play around with this. So this will look at all the genomes, any that match that pattern, it'll add to the genome set. Um, and what's neat about that is you can also choose to leave the pattern blank. So right now I've got the other thing with KBase is the more you have open on your computer, which I have a ton open right now, the sometimes you'll hit some issues with the memory. So yeah, we added that one genome there. Great. But you could also just do all.genome set. So if we leave this blank and run, it'll do the same thing. While it's running, I'm just going to clean up. Deleting is really annoying and tedious in KBase. I just deleted that. I don't really want to keep this around. I'm going to go ahead and delete that. It's not opening. Oh, yeah, so it's started to make that other one. I want to delete this thing. Um, okay, so now it's made that second one. If we want to see what's in there, just to check it, you can click it. It'll open here. Yep, that is the one genome here. It added everything. Good. Okay, so we can click that. Now I'm going to delete these to just clean up. Um, Okay. And so I did that. So what we really want to check though, is the success of what I was really showing as an example, which was adding this one genome to this other genome set. It does tell me the number of genomes that are in the output. That's one thing to check. And here are all the genomes. Realistically, you're probably not going to read through all 697 and check for it, but they do add it in order, so we can look, scroll to the bottom and see that we have that one. If we did want to delete one of these, you can manually delete it here. You can also add a single one here. So another option instead of running that app would have been opening this and manually adding the genome. Uh, but we're not doing that. Scroll up. Okay. And then I'm going to delete this. Okay, so that's the first step, which is add things to a genome set. And then the next thing is we're going to want to build a species tree. There's two approaches to do this. One of them is insert set of genomes into species tree. Um, so that's this app. There's also a beta app that they honestly don't have great documentation for. So it's not ideal either. Uh, so there is, they have this other one that's called microbial tree. Nope. Phylogenomics. Yeah. So they have this other app too. So both of these can be used to make a phylogenetic tree um, of of your genomes. For the normal species tree app, we will um, put our new genomes, which is uh, new.genome set. The thing I don't love about this tool is in this parameter, you're not allowed, it doesn't let you set zero. I would really like it to let us set zero, but we can't. I usually decrease it to at least one. What these neighbor public genomes mean is that the KBase scientists who made this tool kind of benchmarked some different genomes across the phylogenetic tree, based on what genomes are in your genome set, there will be fairly predictable genomes that get added into your tree. Um, I never actually want those neighbor genomes to be present in my tree. So I wish I could set this to zero, but one is the minimum. If your tree is all Ralstonia, the genome that gets added is GMI 1000. Um, if you really want the tree to be super accurate, this means that the tree will actually have two copies of GMI 1000 because we also have that genome present in our genome set. So it isn't the biggest problem. But it does mean when we're making figures for publication quality, we usually go into a tree editor software and just remove the second copy of GMI 1000. So it's a bit hinky, but yeah. So we'll have to name this a tree. So we'll say uh, Tiffany new.genome set. And then, oops, sorry. I do like that it gives errors. So it's like, don't do that. So I want to do new.tree. I don't actually want the output genome set. So this output genome set will be what we put in, as well as this new public thing. So when I don't like the outputs, I've learned to just say like something like temp.delete. And then I'll just keep renaming my trash files temp.delete. And so I just know that they're not useful. And so although they do pollute my narrative, I know that they're trash. Um, okay, and then you hit run. Um, so this particular job, right, has 697 genomes in it. It tends to take like 2 hours, 2.5 hours to run on the cluster. So at this point, go get coffee. Don't expect it to be done particularly fast. While that's running, I'm not going to stay on for 2.5 hours. But I'm going to show a few other tips that I like. So this one thing that's useful in KBase are these info tabs. So this tool that's running has nice documentation where they actually say how the tree is being built. And so it has all the marker genes, so that's really nice. Makes it easy to publish, right? Easy to understand what's going on, easy to publish. This other tool, this other tool is nice because it won't put other genomes uh, into your tree unless you set it to do so. However, um, it doesn't, actually say what genes get used here. So, even when you click this, oh, view full documentation, it brings you to a web page that's not quite filled out. So it is in the beta version. I turned on the beta apps here. So, I can't judge them for not having it be uh polished because it is beta, right? Um, okay, so we have that. In the info, it'll also give you average runtime. So you can see that most jobs are a lot faster. I think most people are not running 700 genomes in these files. So they're not, the other ones are, usually people are getting a faster runtime. Um, if you want, the species tree app can be kind of nice. The settings I usually do are to hide these skeleton species and to have nothing of the skeleton exemplar. What this tool actually does is, once again, KBase scientists have gone in and decided on, in this case, specific representatives of each of the bacteria phyla. And so they call that the skeleton. And so this app will look at whatever genomes you tell to put in here. So you could put your genome set again. Whatever genome's there, it'll be put into a tree with the same skeleton no matter what is here. And that's different than this app where the neighbor genomes here are going to be different choices depending on what genomes you have added into the tree. So it always tries to find, this one tries to find closely related like references. And so that's why when we make a tree with all Ralstonia, the reference neighbor genome is consistently GMI 1000. But if we were to, make a tree of all E. coli, then the reference neighbor genome would probably be some E. coli genome that gets inserted. Okay, so I'm not going to keep running. Well, this will keep running. I'll actually cancel it because I'm not going to use this and I don't need to waste their computing power. Um, Once it is successfully done, you will be able to download it. And I think I have some downloads here. Yeah, so here's a version where, so this was last run a bit ago. This is an old version. So this is what the output will look like on that from that normal species tree thing. Um, Generally, a lot of times in KBase, these HTML things are useful to open in a new window. But this is just an image, so that's not super useful. What is actually useful are these downloadables. What I usually do is download the PDF, and then open that. The PDF's nice because if you want to find, your strain. So. Zooming in. So yeah, here is where we can see that problem of GMI 1000 being in here twice. Um, in this PDF, they do at least highlight their own genome in the purple, so you can be like, okay, that's not what I want. But yeah, here's the version that we wanted in there. Okay. And then the other useful thing is to potentially download the Newick. You do want the one that says, oops, uh, dash labels. Otherwise, this one is just labeled with internal, uh, like the KBase information about where the file is located, which it'll just be named with this like user genome, such, such, such. So those are kind of, not useful unless you're a computer. This one will actually have the labels with whatever you put in your genome. For the narrative we maintain, we try to be really consistent about our metadata with phylotype first, then the strain number, strain name, and then host plant family, um, uh, isolation country, and then the NCBI accession. One annoying thing with KBase is it sometimes will take all of your underscores and convert them into spaces. So that does create some issues with these refseq accessions. Man, this PDF's weird. Not letting me really highlight that. So if we do, need to search that into NCBI, we need to change that space into an underscore. Um, at this point, we have a whole bunch of data in the narrative. I hope it's all accurate. There's definitely a chance that we made a mistake somewhere. So if anything's like surprising in your results, you can always look at pull the accessions up themselves on NCBI and get more details. So, just in case we somehow mixed up one of these genomes and we haven't noticed yet ourselves. I just want to throw that out there that like we at least do try to have the original accession so you can go find the data yourself. Um, yeah. So I think that's it for some quick tips with KBase. I think beyond those things, there are also some useful KBase tutorials. Or is their documentation, which they actually nicely link to. So yeah, their quick start documentation is actually quite nice. The common workflows, these have taught me a lot about the tools that are available. And yeah, we've been able to do transcriptomic analysis on this, do various comparative genomics. It kind of teaches you how to, like these workflows will teach you what apps will create compatible data so that you can, work through a pipeline. So cool. Hope that this works out great for you guys.